Well, this is Dr. Dell, Craig Hane, and the title of this video essay is Bathed in Ignorance, Observations of a Math Teacher. Now, a question I would ask you is how ignorant do you think you are? Ignorance, what I mean by that is simply not knowing something that happens to be true. Now, if you said, well, not very ignorant or very ignorant or anything less than that, then I think you might want to read on or listen on. Because in my judgment, any sapien, which includes both you and me, is extremely ignorant. Now, I'll confess to you that I didn't feel this way until I began to learn more and more mathematics and science and their history. You might say, what? The more you learn, I thought you were getting rid of ignorance. And that's what you'd think. The more math and science I learned, the less ignorant I was becoming. In one sense, that maybe is true, but here's the real deal. Every time I learned something new in math or science, I became aware of many more things that I didn't know, that I was unaware of before. Now that's what I mean by it. The more I learned, the more I became aware of things that I didn't know. My ignorance was increasing. Now furthermore, I began to realize that everything that I was aware that I was ignorant of, there were probably many more things that I wasn't even aware that I didn't know that I was ignorant of. So sure enough, as I learned more and more, the more I learned I was ignorant of. And as I said, this applies to both math and science and many other things too. And the result, quite frankly, is a pretty profound humility, which I think maybe I have today. I really know I'm quite ignorant. Now, in this video essay, I'm going to review a few of the things that we sapiens have been ignorant of for much of our lives. And I'm going to start with math. Let's start with math as an example. This is sort of a historical example. In the beginning, many thousands of years ago, we sapiens learned to count. A number system, very primitive probably. One of my professors once said our original number system was 1, 2, 3 heap. I'm pretty sure that we couldn't count very high, and we couldn't do very much with numbers. We might not even have had good symbols for them. But it was an advantage we have over other species, and so we began to survive against probably extreme odds over other species. Just compare us to all other species. We were definitely the hunted, and when we lived on scavenging and things of that nature. But later on, we sapiens developed numerical systems for counting, which let us count higher and higher, and we began to combine numbers with things like addition and subtraction, and then later on probably multiplication, and then eventually division. And I would think this might have been the beginning of technology. That's a question mark. I don't know. I'm ignorant, but I suspect that technology began to develop about the same time, and they interplayed with each other. Now today, we have something we call the decimal place number system. You know all about it. We take it for granted. And it gives us an ability to combine numbers using arithmetic, which lets us do all sorts of things technologically. This was a very powerful invention, the decimal number system. And sure, we learn it now at a very early age, and we take it for granted, but believe me, throughout most of sapien history, there was no such thing. Just go back and look at Roman numerals, for example. That was a number system, very difficult to use. And of course, today we have technology, modern things like tools, that make this an even more practical and wonderful thing. Now, historically speaking, a long time ago, we began to use fractions in our technology, in our number systems. In fact, the Pythagoreans thought that the only numbers that existed and would ever be needed were positive fractions. They call these, today they're called rational numbers. The Pythagoreans also thought that they could measure something with exact precision. In other words, 1 inch meant exactly 1 inch, and it was not the same as 1.000001 inch. It was exact. Now, they couldn't measure anything to exact precision. They knew that. There was always error, but they thought theoretically it should be exact. And so they also thought that all numbers that would ever be needed to do a measurement would be positive rational numbers. In other words, P over Q, where P and Q are natural numbers. Now, that was a form of ignorance. They made that assumption, but it was ignorant. Because if you do assume exact precision, then the hypotenuse of a right triangle whose sides are exactly 1 unit long, about the right angle, is not exactly a rational number. And the Pythagoreans discovered that. Very, very disheartening to them. In fact, in modern times, we say the square root of 2, which is the length of the hypotenuse, is not rational. We call it irrational. And that was something the Pythagoreans discovered to their horror, and basically kind of retreated from numbers for a long time. But modern mathematicians finally, many centuries later, dealt with it. Now, of course, the length, square root of 2, can be expressed as a rational number to any precision you like. So, for example, 141421356 divided by 1 with a bunch of zeros is a rational number, very close to the square root of 2. But it's not exactly equal to it. So what mathematicians did, humans, sapiens, we discovered a larger set of numbers than the rational numbers, and we call them real numbers. In fact, any number that can be expressed with an infinite decimal expansion is a real number. And then we added negative numbers and zero to that. Now, if it's a rational number, that infinite decimal expansion will be repeating, have a repeating series in it. If it's irrational, it will be non-repeating, and you know all that. And all of this took our ancestors centuries and centuries to discover. In fact, we didn't really discover this thing about real numbers until recent times. But then we also realized that there was not a real number, n, such that n times n, or in other words, n squared, is equal to minus 1. But we also found out we needed a number like that to solve certain math problems. Well, they called that number imaginary. There was no such number, but they didn't think it was imaginary. Well, guess what? After generations of mathematicians debating this, we finally, I'll say, discovered or invented, take your choice, complex numbers. And they do include imaginary numbers. Now, real numbers correspond to points on a straight line, and complex numbers correspond to points in a two-dimensional plane. This is all explained in our Tier 4 of our training. So if you don't know that, you should start taking our training, because if you're interested in modern math and STEM, you'll need to know that. Now, another thing is our ancestors, starting, say, with Archimedes, realized that there might be useful numbers that we call infinitesimals. These are numbers that are smaller than any ordinary real number, but yet they're not zero. And they're very useful as a math concept, and they're very useful in things like calculus. But they don't exist in the real or the complex number system. Now, when I was a student in the 1950s and 60s, mathematicians told all of us there's no such numbers as infinitesimals. Don't think about it. There's no such thing. Shades of our older ancestors. Because guess what? In 1966, mathematicians discovered or invented, take your choice, the hyperreal numbers. And boom, they include infinitesimals. So, some more of our ignorance was removed in 1966. That was a big deal. And by the way, that all revealed the huge conflict we have between heuristic and intuitive reasoning and thought processes and rigorous processes. They're very different. Heuristic and intuitive comes first, and rigorous comes much later and is much more difficult. I talk about that in other videos. Well, then what happened? What size of infinite sets do you suppose there are? Well, our ancestors, up until really quite recently, hey, infinity is infinity. If you have two large infinite sets, they got to be the same size, don't they? Well, the answer is no. There's many different sizes. In the late 1800s, our ancestors discovered that there's an infinity of different sizes of infinity, of infinite sets. Cantor discovered that in the late 1800s. Now, that was quite disturbing, and a lot of our ancestors didn't accept it at first, but it became mainstream mathematics in the 20th century. More ignorance removed? Well, I guess it was. Then there's something called unmeasurable sets. Now, I'm not going to define it. It's a technical definition, but are there such things? Yeah, there are. And they exist even though you can't really construct them. They don't exist in reality, but they exist in theory. And they have unbelievable, unreal properties. What about infinite series? Start out with 1 over a million. That's a very small number. Then add 1 over a million and one. Then add 1 over a million and two. And keep this up. Each time you add 1 over, and the denominator you increase by 1. Now just imagine if you started adding up these terms. You think you'd ever reach 1? Well, you might look at that and say, well, yeah, if I added a million, I might reach 1. What about 10? What about 100? What about a trillion? Think how small these numbers now soon are below anything we could possibly measure physically. They get smaller and smaller. But if you add enough of them, can you reach a trillion? And the answer is yes, you can. In fact, you can reach any large number you want. If you consider this an infinite series, a completed series, it's infinite in size. Now, you stop and think about that. That, from a physical viewpoint, that's hard to comprehend. I've written a whole paper or done a video on the whole concept of infinity and some of the things that it has. But in any event, from a theoretical mathematical viewpoint, this is what it is. And by the way, it took mathematicians a long time to figure this out. But when they did, ignorance removed. Here's another question for you. You know about the Pythagorean theorem. Is it always true? Well, our ancestors thought so for thousands of years. It's Proposition 47 in Euclid's Elements about Euclidean geometry. And that was all it could be. Everybody, well, that's all it could be. It's always true. Ignorance, because it's not always true. In fact, and I've got another video on this in detail, the Pythagorean theorem is almost never true, as any modern mathematician can tell you. In fact, it's only true on the Euclidean plane, which has zero curvature. But it's never true in any of the non-Euclidean planes. There are an infinite number of those, and they have non-zero curvature. It's never true there. Now, our science today consists of a lot of math models. And these math models help us understand a physical system and even make predictions. In fact, our life depends on it a lot of times. Believe me, it depends on it. Every time you get in an airplane, your life depends on the accuracy of some math models. Okay, how good or true to reality are these math models? Do they really represent reality? There are people in the world that say, well, reality is just all mathematics. Well, do they really represent reality, at least the models we've created so far? Well, let me give you an example. There's a simple nonlinear model for a pendulum. You know what a pendulum is, swing back and forth. And there's a nonlinear model that describes it, but it's hard to solve that nonlinear model without a computer to approximate it. So what our mathematician did, our scientists did, they came up with a linear model for a pendulum. It's much easier to solve and use, and that's what we often use for a model for a pendulum. Now, the motion of a pendulum can be predicted quite accurately with this linear model in many cases, but it's not how the pendulum really works in some cases. In some cases, this linear model gives a totally erroneous prediction. Can't even imagine its behavior in the real world, because the pendulum now behaves in a way that we can't predict its motion, and we call it chaotic behavior. Now, the nonlinear model, which is much more difficult to work with, does predict it. And I'll tell you what, we didn't understand this until the late 20th century. Ignorance. Are there an infinite number of prime numbers? Well, our Greek ancestors discovered the answer to that is yes. They could prove it. Okay, what about a prime triple? 2, 3, 5, that's a prime triple. 3, 5, 7, that's a prime triple. Are there any more of them, an infinite number of them? In fact, the answer is no, there aren't. In fact, there aren't any more than these. There are only 2. And we can prove it. Okay, what about prime pairs? 11, 13, 17, 19, and so on. Are there an infinite number of those? Well, we can find a lot of them. And we don't know any end to what we can find, but no one knows the answer to this question, so far as I know. In fact, I'm pretty sure they don't. If you could answer this question tomorrow and prove that there was an infinite number of them, or that there was only a finite number, either way, If you could answer the question, you become world famous as a mathematician, and you'd be set for life. So we're ignorant. Now, any mathematician can write down an unlimited list of things that we don't know. And in fact, the more we learn, the more things we know we don't know, the bigger this list gets. For example, is there an axiomatic math system? All math models are based on some axiomatic math system that would give us a better model of the physical universe than the ones that we've already discovered or invented. Now, no one knows the answer to this, but I would emphatically say absolutely yes. Why? Well, to date, throughout history, mathematicians have continually come up with new axiomatic systems that are better than the models we had for the old ones. Euclidean geometry was used by Newton for his physics. Great model, great. We still use the Newtonian model for many, many things. But there's things it doesn't work for. For example, you couldn't make GPS systems that we use today on our smartphones with Newton's model. It took new mathematics to make a new model. Einstein did that with relativity theory. And then new mathematics and more models for quantum theory, and so on. Is there a perfect axiomatic system? Is there a perfect model even? And I would bet the answer to that is no. Let's look at some examples. We have a thing called Darwinian theory of evolution that is generally accepted today by science. Is it adequate to explain life on Earth today? I think absolutely not. It's a very incomplete theory. There's certain things that it can predict, but there's many, many things it doesn't predict. For example, it does not give any idea of how life got started. And we don't have a theory that explains that. We don't have even a heuristic theory about how life got started. Well, that's not true. There are people that claim we have heuristic theory, but believe me, they're not very good, and there's nowhere near a model. Well, we discovered something observationally called dark matter. Do we have a math model for it? No. There's another thing we discovered, different, called dark energy. Do we have a math model for it? No. We don't have a scientific model for either one of those. We don't know what they are. They're trying to come up with models. Climate change is a big hot topic today in 2019 when I'm making this video near the end of 2019. Do we have a math model that can predict climate change accurately? No, not even close. Our math models for climate are not predictive at all. Now, they claim they are. That's the hubris that some people have. I don't know whether it's the scientists or the politicians. I think the scientists go along with the politicians. I think any honest scientist knows that our models are not predictive. They're just that's not even a debatable thing. If you show me a scientist that actually believes that these models are predictive, I'll show you a very ignorant scientist. What about the economy? We're all concerned about the economy. We all depend on it. Can we predict its future? No, I don't think so. We've never been able to in the past, and I'm pretty confident we can't do it today. 2008, the great financial crisis that we're still, in many sense, we're still recovering from, or at least we're dealing with the after effects of it. We don't understand it. We have zero interest rates today worldwide. Nobody understands that. We don't understand the monetary systems today. I think most people don't even understand monetary systems today. Can we predict or foresee what technologies are going to exist and look like in the future? I think if you think so, you're being very hubristic. We've never been able to do this in the past. Go back and look at past predictions about the future. Now, some were accurate, but some were just absolutely crazy and didn't even come true. Here's a question for you. Is there a non-physical part of our reality? We live in a physical world, and our science models today all deal with the physical world. Is there a non-physical part of our reality, of the world we live in? I'm pretty sure there is. But our current science doesn't recognize it. There's no model for it in our mainstream science. But look at the work of Dr. William Tiller. I think he's the modern Galileo. He says, yes, there's a non-physical part of our world, and he has got a model for it. And more importantly, he's got experiments to demonstrate it. In fact, I think that's our most significant scientific ignorance today, is our ignorance of the non-physical world. We just assume that the only thing that's there is the physical world. And I think that's far, far from true. Now the list just goes on and on. This expands. The more we learn, the more we know we don't know. In fact, I'll tell you a little secret. When I go to a party where there's a lot of intellectual, educated people, and we talk about a lot of things, as the party moves on, I like to brag. I say, well, I think I might be the most ignorant person at this party. Now, I do this after we've already discussed some pretty esoteric things that they know a little bit about. And so then they look at me and they go, well, you talk about all these things we don't know about. How can you say you're the most ignorant person? Well, I think you know the answer now. Let me just tell you a few of the topics I like to discuss with people that want to talk about them. And most of these topics do require some basic math ideas and knowledge. And by the way, most of the math that you need to understand these things you can learn in my 6-tier training. You don't necessarily need, well, that's not totally true. You need some more advanced math for some of them, but a lot of it you can understand. Okay, let me give you some examples. AI, artificial intelligence. Well, I like to talk about convolutional neural networks and big data and the new thing called inference. These are all things that are related to AI, and it's extremely powerful and important today. It's extremely important technology. And then we have something we're all worried about or thinking about called artificial general intelligence, AGI. And some people are predicting we're going to have it by 2028. I don't know. I'm not predicting it, but I think it's possible. And then there's something that we worry about called artificial superintelligence. When will that happen, and what does it mean? What are the implications? I have some real ideas about that most people don't think about. And what I like to talk about when we talk about that are microtubules and qubits in our neurons. This is something brand new that people like Roger Penrose are talking about. And it totally changes our idea of how the brain works and how consciousness might work and how we might communicate with the non-physical world and so on and so forth. This, to me, is right on the forefront of modern science, and very few people even know anything about it. So when this comes up at a party and I expound on it a little bit, they go, wow, I never heard of it. What about quantum computers? People have heard about them, and now we're beginning to build them. Google just released one recently. There's other companies doing it. And what are their implications? Well, they have huge implications. For example, all of our current cryptography is going to fail now. So how are you going to, send encoded messages? I mean, it's a big deal. Quantum computers are going to revolutionize our world that we live in. William Tiller's work I mentioned earlier, and what I call supramatter, that's non-physical matter, that works greater than the speed of light. In fact, it works in a non-space-time universe. I don't want to get into it, but anyway, you can study Tiller stuff if you want to. G5, today in 2019 and almost 20, G5 is our new communication technology that's going to be replacing G4. And it has profound implications to all of our lives. It's going to change our lives dramatically. One example of that is going to be autonomous vehicles. G5 and artificial intelligence are what's going to really make them work. And then I like to talk about Tesla and what it's done. It has more data for self-driving cars than any other company by far. Big data. It's also developed a NVIDIA board replacement, and that's a big deal too. NVIDIA board is a GPU board. Sometimes this comes up at a party or when I'm talking to people. Another thing is CRISPR-Cas9. This is going to create a biology revolution. It is already creating a biology revolution. It's also, by the way, all these technologies have wonderful, wonderful things that could come of them and also horrible things that could come of them. AI, and especially AGI and ASI, people are scared of it. This CRISPR-Cas9 could be used in a horrible way. Then there's new technology, blockchain technology. A lot of people don't know anything about them. They've heard of Bitcoin, which was the first blockchain technology. Other cryptocurrencies get way beyond that. Blockchain technologies is probably going to revolutionize the world we live in too. If I'm talking to people that are interested in the economy, I like to talk about what I call the fiat money myth. People don't understand money today hardly at all, and I like to talk about that and go into it. And when you get into it mathematically and start talking about it, it's really amazing. What about quantum theory and relativity theory contradictions? That's the big problem in physics today. It's a huge problem. There's no solution to it at this point in time. What about the singularity Ray Kurzweil talks about? What does that even mean? What are the implications of it? I have ideas about it, by the way, and I won't get into it on this video. It takes too long. I believe the future of sapiens in the more distant future is O'Neill cylinders. Jeff Bezos, I think, believes in that too. That's why he's devoted Blue Origin to creating infrastructure for us to start building things like this in space. Today, income inequality is a big topic. A lot of people hate it. I think it's inevitable, and I think it all could be good. It can be bad. It's like a lot of things. It can be good and bad, but I think it's inevitable. It has to do with the amplified Pareto principle. I'll talk about that sometime. What about fusion energy? That's right around the corner today. There's reason to think that AI is going to help us develop fusion energy. In the meantime, fission energy can be made safe, and we could be using that. There's a big controversy today about carbon dioxide and climate change and energy, and they think that windmills and solar panels are going to solve the problem, and they're not. Simple mathematics demonstrates that's not going to happen. Fusion energy can make it happen. Actually, so can fission energy. Peter Zeihan has an analysis of the world situation today. The breakdown of the Bretton Woods agreements, the collapse of what's happening today. He has a lot of prophecies. I'd like to talk about those because I think it really shows us, as of 2019 and 2020, what's likely to happen in the 2 or 3 decades ahead. What about population demographics? That's a big deal he talks about, but I think it has implications for people that even Zeihan, well, I think he might realize it, but I think it's going to change the way the world. For example, I think the world in the next 2 decades is going to become more religious than it is today. Now that seems very counterintuitive to people, but if you understand population growth among the different segments of population, you'll understand why. I like to talk about political tribes, Amy Schua's new book, because today we're seeing more and more of that with modern communication technology and social media. We're seeing more and more political tribe stuff, and it's very interesting to look at. Well, these are some of the things I like to talk about. So, and mathematics, by the way, helps me with all these things. I don't think I can understand any of these things without understanding mathematics. So that's one reason why my mission is to help every person get the math they need for their life, for their career, and for what they're doing. And by the way, you can get all the math you need for all of this today very quick and easy. It used to be very difficult to get that math, but modern tools like Wolfram Alpha, for example, make it very easy. And that's what I do in my 6-tier training program. And so you might want to go take a hard look at that if you're interested in any of these subjects and want to learn more about them. So this is Dr. Dell. I hope you've enjoyed it, and I wish you the very best success of becoming more ignorant as you grow on. Maybe I hope some of you someday can become a lot more ignorant than I am. See you on another video. Bye-bye.